Valley fever is a primarily mosquito-borne, multi-species zoonotic viral disease. The causative organism, Rift Valley fever virus, was first isolated in the early 1930s in the Rift Valley in Kenya. It is the cause of severe disease in small stock, resulting in high mortality and abortion storms, particularly in sheep and goats.
It was at Lake Naivasha, and there's some mountains there on the edge of the Rift Valley, and they moved the sheep up the mountains, and the outbreak stopped, and they put some sheep in mosquito nets, and they put some outside of mosquito nets, and they even caught mosquitoes, and they transmitted with them. So they tied the whole thing up that this was a mosquito-transmitted disease associated with heavy rains, abortions, lamb deaths, and human disease.
In the 21st century, there's an increased risk of the introduction of this virus into regions free of the disease, such as Europe and Asia, as a result of the high numbers of competent insect vectors in those regions and the intensification of international trade in live animals and the unknown impact of climate change. Rift Valley fever is a good example of a disease where the principles of the One Health concept are applicable. Proper studies or control strategies of Rift Valley fever require a more integrated or holistic approach to human, animal, and ecosystem health and collaborative efforts of multidisciplinary teams working nationally and internationally. The expected environmental or ecosystem changes in large parts of Africa as a result of climate change may well have a significant bearing on the dynamics or epidemiology of the disease and frequency of outbreaks in animals and humans. An attempt has been made to utilize satellite imaging to predict Rift Valley fever outbreaks through the development of a green vegetation index as a marker of DAMBO or broad flay flooding, or the effects of the El Niño Southern Oscillation, ENSO phenomenon, as a long-term predictor of heavy rains. Thus far, observations on rainfall patterns and ENSO phenomenon have been found to fit most past outbreaks of Rift Valley fever, but have not been used successfully to predict outbreaks. For most of the 20th century, outbreaks were confined to countries in Africa. The virus was isolated for the first time outside continental Africa in 1979 in Madagascar, where the virus is now endemic. In 2000-2001, Rift Valley fever virus was introduced across the Red Sea and caused a major outbreak of disease in livestock and humans in Saudi Arabia and Yemen on the Arabian Peninsula. During 2008, it was detected on the French island of Mayotte in the archipelago of Comores, located between Mozambique and Madagascar. The disease was first recorded in southern Africa late in 1950, when an estimated 100,000 sheep died and 500,000 ewes aborted in South Africa alone. A second severe epidemic occurred in southern Africa in 1974 and 1975, during which more severe losses than in the 1950 epidemic were reported.
The thing about the 74-6 outbreak is that human deaths were recognized for the first time. And what actually happened was in 75, a couple of young Australians were hitchhiking in Zimbabwe, and they picked up Marburg infection, got sick as soon as they crossed the border, and he died here. His girlfriend got sick after him, and then a nurse got sick. There was no television at the time, but it was in the newspapers and radio and so on about this hemorrhagic disease, and it was a big, frightful thing. And consequently, doctors opened their eyes, went into the wards and saw people bleeding. In other words, patients with bleeding tendencies and bleeding problems. And they sent in specimens to the lab, and it was confirmed to be Rift Valley fever. And that's how it was discovered, by accident.
Recurring outbreaks of Rift Valley fever took place in South Africa between 2008 and 2010. It re-emerged in 2008 following good rains in Mpumalanga province, with subsequent spread to 3 more provinces. In 2009, limited outbreaks occurred in 2 provinces, which were followed by a widespread outbreak in 2010. The 2010 outbreaks occurred in 5 provinces of South Africa and in neighboring Namibia and Botswana. It was characterized by significant livestock losses, more than 220 laboratory-confirmed cases in humans with 26 deaths, and deaths in a small number of wild antelope species. In 1977 and 1978, a major epidemic occurred in the Nile Delta and along the Nile in Egypt, causing an unprecedented number of more than 200,000 human infections and the death of about 600 of them. This represented the first time the virus was recognized north of the Sahara Desert and was associated with the construction of the Aswan Dam and subsequent flooding of large areas along the Nile River. Numerous deaths and abortions in sheep and cattle, and some losses in goats, water buffaloes and camels were also recorded. Other noteworthy African outbreaks in which high mortality in animals and deaths in humans were reported include the outbreaks in Mauritania and Senegal in 1987, Kenya and neighboring countries during 1997-1998, and a particularly large epidemic in Somalia, Kenya and Tanzania in 2006-2007. Rift Valley fever is caused by a virus of the family Bunyaviridae. No significant antigenic differences have been detected between Rift Valley fever virus isolates and laboratory passage strains from many countries, notwithstanding the fact that RNA genome segment reassortment had been reported both in susceptible species and in laboratory cell cultures. Differences in pathogenicity, however, have been demonstrated. Wild-type Rift Valley fever virus, which is hepatotropic, has been attenuated to produce vaccine by serial passage in highly permissive systems, such as suckling mice or tissue culture, by selection of small plaque variants, and by chemical mutagenesis. The Smith-Burn vaccine, which has been used extensively to control outbreaks, was developed by 105 serial intracerebral passages in suckling mice, until it lost its tropism for the liver and became neuroadapted. With the exception of the 2000-2001 outbreak on the Arabian Peninsula, all other outbreaks of serological evidence of Rift Valley fever have been limited to the African continent, Madagascar, and the Comoro Islands. Epidemics associated with above-average rainfall have tended to occur in eastern, central, and southern African countries, usually at irregular intervals of 5 to 15 years or longer. In these regions, sporadic cases or small outbreaks occurred between epidemics. The recent outbreaks of Rift Valley fever in countries in North and West Africa occurred independently of rainfall in dry regions, apparently in association with vectors which breed in large rivers and dams. The central enigma in epidemiology of Rift Valley fever has always concerned the fate of the virus during the inter-epidemic periods. For decades, it was widely accepted that the virus is endemic in indigenous forests, where it circulated in mosquitoes and unknown vertebrates, and that it spread to livestock rearing areas when heavy rains favored the breeding of epidemic mosquito vectors. However, there is no proof that the virus is maintained in transmission cycles in birds, monkeys, baboons or other wild vertebrates.
This is particularly for Culex mosquitoes, so it's slightly different for the Aedes. Effectively, from an egg raft like that, you get larvae which go through 4 different larval stages and into a pupal stage. And the pupa normally sticks around for only about 2 days. And effectively what's happening is you're getting metamorphosis from a larval stage to an adult. And after the 2-day period, you'd get emergence of the adult mosquito fully formed out of this pupal cast. And it will stand around and spread its wings, and eventually the cuticle and so on will harden, and the mosquito will be able to fly off.
It is currently postulated that Rift Valley fever virus in sub-Saharan Africa is maintained in inter-epidemic periods, principally by transovarial transmission in Aedes mosquitoes, particularly in areas where there are dambos or broad flays, with a low level of transmission to livestock or wildlife. Pans, dambos and flays retain water for months or even years, and constitute an ideal environment for the breeding of mosquitoes, particularly flood-water breeding Aedes of the subgenera Aedemorphus and Neomelaniconium, which attach their eggs to vegetation such as grasses, sedges and rushes at the water's edge. In contrast to kilocene mosquitoes, the eggs of Aedes have to be subjected to a period of drying as the water recedes, in order to hatch on being wetted again when next the pan, dambo or flay floods. Thus, Aedes mosquitoes overwinter as eggs. The eggs can survive for long periods in dried mud, possibly for several seasons if pans, dambos or flays remain dry.
The Aedes species tend to lay individual eggs, and they dot them around on moist surfaces. And they would lay around the sort of dried mud that surrounds the water body in a pan or in a dambo. The Aedes mosquito would lay probably around about 70 to 120 odd eggs at a batch. She only needs to be inseminated once, and then she can just feed, lay eggs, feed, lay eggs. The same goes for the Culex, of course, but they lay their eggs in a little egg raft, and that can be between 80 and 150 eggs in a little raft like that. And these guys, of course, when they lay eggs, it's done en masse.
Maintenance of virus during the inter-epidemic period is therefore possible by means of transovarial transmission by Aedes species. Serological surveys in cattle and wildlife indicate that varying amounts of virus activity occur each year in certain areas in eastern and southern Africa without epidemics occurring. In southern Africa, the onset of epidemics tends to be recognized late in summer. It is thought that epidemics are precipitated by abnormally heavy rains, which lead to an explosive increase in epidemic mosquito vectors and spread of the disease from these endemic foci. The flooding of dambos or flays and the humid weather conditions prevailing in epidemics favor the breeding not only of the Aedes maintenance vectors such as Aedes macintoschi, Aedes unidentatus and Aedes juppie, and the non-Aedes mosquitoes such as Culex and Anopheles species, which serve as epidemic vectors. And in these mosquito species, The transmission is biological. Transmission in other biting insects, such as midges, phlebotomids, stomoxids, and simulids, is mechanical because of the high level of viremia in infected livestock. Contagion is not considered to be important in livestock. Although a wide variety of domestic and wild ruminants are susceptible to Rift Valley fever, the disease is mainly of economic importance in sheep, goats and cattle, with newborn animals being most susceptible. Seroconversion has been found in a range of African antelopes, camels and African and Asian buffalo, sometimes accompanied by abortion. Deaths in wild animals are rare, but mortality has been reported in several wildlife species, including African buffaloes, waterbuck, giraffe, sable and springbuck.
Mainly a mixture of Anopheles and Culex, but also a lot of Aedes species in here.
The epidemiological characteristics of the disease justify the perception that the unusually wide range of mosquitoes that can transmit the virus and the sufficiently high levels of virus that circulate in livestock to infect mosquitoes would render many parts of the world receptive to the virus.
When you take the fact that there are tens of billions of birds which migrate north-south, waterbirds, waders, etc., every year, targeted for mud, and they fly from one pan to another with mud on their feet, is that not a mechanism? And in fact, in 1974, when Rift broke out in Namibia, that in Namibia there were people of 80 years old who'd actually not seen the kind of birds there that in their lifetime. Suddenly they had flamingos and all sorts of things in their thousands in the pans in that desert. So is that a mechanism? I'm still trying to prove that. I've been trying to catch birds and wash their feet and all that. People think I'm crazy.
The vast majority of human infections result from direct or indirect contact with the blood or organs of infected animals. The virus can be transmitted to humans through the handling of animal tissue during slaughtering or butchering, assisting with animal births, conducting veterinary procedures, or from the disposal of carcasses or fetuses.
Het 'n deel van die vrugwater het nog vasgesit. En ek kon haar nie net so los nie want daai vrugwater maak ook koors. En ek het nie geweet nie, wel dit kan as gevolg van die slengtaal wees of dit kan as gevolg van daai sak wees wat daar vassit. En ek wou daai sak probeer daai deel uittrek. Ek dink dit was omtrent 'n week en 'n half gewees na die tyd, ja. Ek het hierdie ontsettende koors gehad en dan het ek gesukkel om asem te kry. Dit was vir my sleg geweest.
Certain occupational groups such as herders, farmers, slaughterhouse workers and veterinarians are therefore at higher risk of infection.
The right here is in fact at the dairy farm where the vets were sampling bloods, and vets never wear gloves. Actually, these two pictures are misleading. Vets mostly never wear gloves, or the gloves are quite short and they've got holes in them. This is something human doctors would never do. But if you look very closely at this picture, there's blood all over those tubes. So why are you surprised when you get exposed in these procedures?
The virus infects humans through micro-lesions in the skin or mucous membranes, or through inhalation of aerosols produced during the slaughter of infected animals. Aerosol transmission has also led to infection in laboratory workers.
The blood or the fluid or whatever might splash into your eyes, and then that is a direct infection.
The pain on the shoulders, the elbows and the knees is very terrible. and I got some dizziness.
My symptoms was a headache, terrible headaches, and neck aches, and back aches, and nausea, and no listless, and not eating well, and so you lost a lot of weight.
There is some evidence that humans may also become infected with Rift Valley fever virus by ingesting the unpasteurized or uncooked milk of infected animals.